All right. Hello, everyone. Welcome to the last session for today. For those that don't know me, I'm Kristen Kennedy. I currently work in Ed Plus, but before that, I worked in enterprise technology. And I had the great pleasure of bringing Alteryx here, not only because I liked the product, but many people found it. See, look at that, you guys. So people had gone to sessions, they really liked it, and the thing we kept hearing over and over is how much fun it was, and you don't hear that a lot with data tools, so we took that as a good sign. So and I want to say that Alteryx has been a great product, but also I personally have really enjoyed working with them as a company. They've been just really easy to work with, so if you have questions and anyone in ET can't help, always reach out to Alteryx directly. They've really been super helpful over the time. So with that, I will introduce Alan Jacobson.
Thank you. So nice to be here today. Again, my name's Alan. I'm a data geek. They give me this lots of title type things like data and analytic officer. It just means I like playing with data, which is what we're going to try to do a little bit of today. So I'll give you some PowerPoints, but then I thought we'd actually grab some data, put the product on the screen, maybe build a model or something, have some fun. Does that sound good to everybody? Yeah. Show of hands, how many people are actually users of Alteryx? Because that'll give me a sense of where I'm entering the pool. So about half the room. Okay. So I'll try to make this so that everyone gets something out of it. If you've never seen Alteryx, you'll learn a little bit about Alteryx. If you have used Alteryx, hopefully I'll show you something that maybe you haven't seen before. Does that work? Yeah. All right. So for those of you who know nothing about Alteryx, having skills at using the tool is actually probably a pretty good thing from a career standpoint. Alteryx is used by about 50% of the global 2000. So if you went to the 2000 largest companies in the world, about half of them, 49% of them, use Alteryx today. And if you took the largest, most successful companies in almost any industry or segment, it's not a 50% market share, it's like a 70 and 80% market share, which you can see by those numbers on the left. I joined Alteryx from Ford Motor Company. I worked at Ford Motor Company for about 25, 26 years. The last thing I did at Ford was set up a data science team and ran data science across all of the different areas of Ford. Kind of a fun company if you're into data science, because it's not only a manufacturing company, which is probably what you think of when you think of Ford. And certainly I got to do some cool analytic use cases for manufacturing, but it's also a bank. Did you guys know Ford was a bank? Yeah, when you get a loan for a car, and it has to follow all the banking regulations of a bank. So it's basically a bank. So you got to do credit ratings and things like that. So it's a bank. It's a performance sports / entertainment company. Anybody watch NASCAR? Ford won every one of the series this year, all three of them. And so, yes, I would sit in a trailer at a NASCAR track doing data and analytics for races as well. So it's a pretty fun place if you like data and analytics, because you can do manufacturing, you can do banking, you could do sports analytics. And yes, Alteryx is used for all of that. If you ask what is Alteryx really all about, I would actually argue it's not about a specific use case. If I asked you, what do you use Excel for? It'd be hard to articulate like the use case for Excel. Use it all over the place. Alteryx is quite similar. I view it as an upskilling platform. So this is considered an analytic maturity framework where companies get rated on what stage of analytic maturity the organization is in. This is from the International Institute of Analytics. They've assessed thousands of organizations. The average company scores, I used to say a pretty middling, but it's not really middle because the scale goes from 1 to 6. 2.2 out of 6, at least when I was in school, that was not a grade to be proud of. Like, that's pretty awful. That's the average company today. About 80% of companies sit in stage 2. What stage 2 means is if you showed up at any random department, like you knocked on the tax team's door, the accounting team, or marketing team's door, and you asked a data-driven kind of a question, and you wanted them to automate a process or build a model or do one of these things that's maybe beyond a spreadsheet, if less than 10% of the people in that department can do it, they are probably squarely in stage 2. Does that make sense? Where do you think ASU is? What stage?
4.
Really? So the most advanced company on the planet, any idea what that organization might be? Everyone in this room uses this company on a regular basis, I am sure. What was that? Apple. They are very advanced and they are a huge Alteryx customer, but no, it is not Apple. According to IIA, this isn't my opinion. What was that? Amazon. You got it in 2 guesses. That was pretty good, right? Amazon is considered the most advanced in the world. And any idea what their score is? They are in stage 4, not in stage 5. So if Amazon is in stage 4, do you think ASU is still in stage 4? You think you walk into any department and over half the people can automate a process, build models, do all those things? Probably not. Yeah. So the reason why organizations want to do this is that becoming more analytically capable translates to dollars. This is true for organizations. This is also true for you as individuals. You'll be able to get more jobs and higher paying jobs if you can use analytics and make data dance in more advanced ways. When you go from stage 2 to stage 3 to stage 4 as an organization, the revenue and the profit of those companies go up. This again is from IIA, but Forrester has done similar things. Gartner, many consulting companies have these frameworks and they get the same results. So almost every company on the planet knows that they need more people that are analytically capable. And what they're trying to do is arm their knowledge workers to have these data and analytics skills. So the knowledge workers are off on the right. Those are the folks that work in all the different departments around the company that aren't the data scientists or the tech team. And then you've got blue people on the left. And they don't always go by the name data scientist. They could go by other titles. I'll call them blue people for right now. And if the way you have to solve a problem is if any time a question comes in on the right, you have to throw it over the wall to a person on the left, you're probably not going to be very happy with how that process works. Have any of you done this? Like you have a really hard data question and you like throw it over the wall to somebody else to answer the question for you. Not only do you have to probably take a number and wait because there aren't enough blue people to just answer it, but even if there were enough blue people, like what's driving attrition? And I throw it over the wall and the blue person immediately does the analysis and they come back and they say, well, the data would suggest the following. It's very likely that the green person says, well, wait, if the data suggests that, then I asked the wrong question. Let me try a different question. It goes back and forth and back. Has that ever happened to anybody here? And the Harvard Business Review has studied this and said there's a 0% satisfaction with companies that are set up doing that. I don't think I've ever heard a lower satisfaction rating than 0% satisfaction. Like nobody likes it. The blue people don't even like it, right? They don't like that people are coming to them asking for bar charts. They're like, I didn't get a data science degree to build a bar chart, right? So no one likes it. So what we're trying to do is upskill the green folks, make them a lot more capable, and have a tool in Alteryx that both parties can use so that they can work together versus being in two totally different technology bases. All right, enough PowerPoint. You guys ready to play with data? Oh, and they got me a stand. This is good because driving a computer while holding a microphone is really not a good thing. Okay. Everybody can hear me okay still? Yeah? All right. So I'm in my Analytic for Kids folder. You guys are not the kids. Though you are pretty young, but you're not the kids. I have 2 kids. When they were 12 and 14, they both became certified in Alteryx. So the platform is pretty easy to use. We're going to do examples that my kids did. So I'm sure everyone here will be able to do them if they want to do them. So I'm going to go into the Analytic for Kids folder. If I can click. And these are a few model things that my kids built models to answer questions. One was based on US crime. We were looking at crime patterns in the US. That is way too depressing. We are not doing that. Second one was soccer modeling. We were trying to figure out who was going to win the Women's World Cup. You guys already know the answer because it already happened, so we're not going to do that one. Running analytics. My older one was trying out for a soccer team. He needed a good time on a 2-mile run. He had to get 6-minute miles. And he thought AI and ML was going to help him get a better time. So he's analyzing, hey, if I eat more pasta or if I sleep more, like what are the factors that result in a better time? I told him to go out and run more. He said, no, AI and ML, it's going to get me there. He made the team, but I think he just wanted to eat more pasta and was trying to develop the data to show me that pasta was good. I'm going to do education and income this morning. So the question I asked my kids, is great that we're at a university for this one, is I can pull standardized test data off the internet. So education scores on standardized tests for reading, math, and science. So I just drop the data into Alteryx here. I have a list of countries with reading, math, and science scores. And I got this file off the internet. This was an Excel file that had standardized test scores by country. Make sense? When you read articles in the paper about which country is the smartest, this is typically the file they use. Now, I don't want to get into the debate of whether standardized testing is a good measure of intelligence. We'll put that aside for a second, but we'll just have some fun with the data. Does that work for everybody? Okay. So the second file I grabbed was income by country. And the question I was going to ask my kids is, do you think in countries where they do better on the tests, Do you think they make more money? Do you think studying in school and getting better scores on standardized tests results in more income? And then we could talk about correlation versus causation. Is it because you make more money that you're doing better on the test, or is it because you're doing better on the test that you're making more money? But we'll just play with the data a little bit and see what kind of correlations we find. Does that make sense? Everyone's good? And I asked them other questions like if the countries had more patents, if there were more women that were able to work in those countries. These are all data files I can get off the internet. Percentage of women that work in countries, does that help everyone's income in the country? Kinds of questions. Make sense? We'll just do the income and education one today. So I'll drag the income file in. This is in a different format. This is a CSV file. It's from the World Bank. It has a list of countries and the per capita income, the average amount of money people make in those countries. Make sense? So I just brought in two files, in this case, an Excel file and a CSV file, but the files could have been in any format. It could have been a Google Earth KML file, so geospatial. It could have been a JSON file, maybe a badge reader somewhere on campus. You're going to be able to read in data that's in just about any format and just about anywhere. It could be on a cloud-based data store. It could be in a system like PeopleSoft or Anaplan or SAP or Oracle, just about any place that the data sits. You're going to be able to access the data as long as your credentials get you to the data, and read in the format. And once the data is in Alteryx, once I have these in Alteryx, I don't need to know anything about the format of the data. Now it's just a data frame. So all of the capabilities of Alteryx, the reporting, the geospatial capabilities, you can see lots of tools down here, text mining, computer vision, machine learning, all of these capabilities, I'll be able to exercise on any data. Good so far? All right. So the first thing I need to do in order to be able to do this analysis is smash these two files together, because what I want is a country, the test score, and then right next to it, the income all in a row. So instead of two files, I got to smash it together into one file to do the analysis. I'd have to do this in Excel if I were in Excel, right? You get two tabs and you got to smash them together. Do most people here use Excel to do their analysis of data? Is that the most common tool? What do you guys use if not Excel? What do you use? Alteryx. There you go. Python, right? So we'll compare this to doing it in Excel and doing it in Python and doing it other ways, right? So if I were doing this in Excel, the command to smash these two files together to make them one file would be what? What's it called again in Excel? Take two tabs and you VLOOKUP. That's it, right? So I'll come up here to the search bar and I'll type VLOOKUP. By the way, my kids have no idea what a VLOOKUP is. And it tells you that's a join. That's called a join. In the data and analytic world, that's the proper name for this. It's called a join. I can click here and get examples of how to properly do a join. It has help articles that if I know how to do a VLOOKUP, here's how to do the equivalent thing with a join command that you're used to doing with a VLOOKUP. So the help and kind of the upskilling is built into the platform, right? Now, if I know it's called a join, I might notice that there's a whole folder of join tools, fuzzy matching if the names don't exactly match, join, and I can join the data together like that. Make sense? I tell it what I'm going to join it on. I'm going to join on country in one file. I didn't even have to pick the other one. It saw that there was a column named country, so it picked it. So it's matching the country in one file to the country in the other file. And there are three outputs to the tool, L, J, and R. And it shows nicely with a Venn diagram what comes out each. So out the J is where the countries of the top file match the countries in the bottom file. In Python, what's that called? Inner join, right? Inner join. If I put my mouse over this, it'll say inner join. But the beauty here is, like my kids, they didn't need to know what an inner join was. As long as you can read a Venn diagram, you're good. Make sense? And that's what this tool is all about, is letting everybody be able to quickly and easily do this stuff. You're going to get the same answer, whether you use Python, Excel, Alteryx, SQL. It's the same math, right? It's the same logic. Hopefully this is fast and easy. I could change the names of the columns. I got these from the internet. I want to give them nice short names. So read, math, and science are the key columns I want. The income, it read it in as a CSV file. Excel does the same thing. The number, the income number, it changed it to text because it was in a CSV file. So it interpreted it as text, but I don't want the number to be text. I want it to be a number. So I'll change the data type. So I just changed the 3 column names, changed the data type, and I actually did 3 different types of joins, the left outer, the right outer, and the inner join. And I did it pretty fast. Can you do it that fast in Python? Be pretty tough. pip install pandas, like, it would take me a little while to type that out. This, if I weren't talking, this is probably going to be pretty fast. The other thing you'll notice that I'm doing here is I'm building a process flow. Eventually I could put this on a schedule and automate this so that I can do this repeatedly. Pretty cool. Yeah, you guys having fun so far? Okay, so now that we have the data joined, and I'll show you what the data looks like here joined, we've got a list of countries, we've got read, math, science scores, and it's joined it up to the matching country and the income of the country. It's now all in one nice frame. The next step, before I do the analysis, we should do the hypothesis, right? It's data science, so we start with the hypothesis. Do you folks think that doing better on tests correlates to making more money? Do these things correlate to each other? I see some nods. Yes, you're in education. I would hope you would say yes. Yes, they indeed do correlate. Otherwise, I'd be a terrible dad. Thank you for the vote of confidence that I'm a good dad, because what a terrible dad moment if you're teaching your kids not to study in school. That would be pretty terrible dad. So I'm going to ask a harder question. Reading, math, or science? If you want to make the most money, which do you think you should study the hardest? Reading, math, or science? Those that think reading, raise your hand. No one. Okay. Those that think math, raise your hand. Whoa, landslide victory to math. And those that think science, raise your hand. A few votes for data scientists like that answer. Science. Yeah. Actually, I think data scientists probably take more math classes than science classes. So I take that back. I like the math better. Okay. So now we just did the gut feel. Now we're going to go from gut feel to actually trying to use the data to answer the question. Does that work for everybody? So we have R and Python built into the tool. You can actually write code in either, but you can also use the drag and drop method. And I'm going to do an associativity analysis using an R library. You can see the R logo on the tool. I'm going to tell it I want the correlation of all of these fields to each other. I'm going to use the Pearson correlation coefficient to see how they're correlated. I will hit run. It's now grabbing the latest data. If I had just updated the data files on my hard drive, it's getting the latest data from right now. It's joining it together. It's linearly regressing all of these things against each other to tell me which things correlate to each other. It's going to build me what's called a correlation matrix. If you've never seen a correlation matrix, no fear. Alteryx will explain to you how to read it as well. So I'm going to open up the window here. Here's the correlation matrix. It explains in plain English how to read the box, the more positively correlated the things are to each other. If we saw blue, blue would be negative correlation. That would be I did better on the test, but I made less income. That's negative correlation. And white would be scatter, no correlation at all. So we can see all of these fields positively correlated to each other. Income to reading is a 0.39. So I'm glad none of you voted for reading. Income to science, 0.41. And congratulations to all of you who voted math. Income to math, 0.44 positively correlated. So math is the most positively correlated thing. But for those that guessed science, it wasn't a bad guess. It turns out the tests are highly correlated to each other. So it turns out once you know what the kid gets on the math test, you pretty much know what they're going to get on the science test. It's highly linearly correlated. Basically, the kids that do well on one test do well on all the tests, and the kids that do poorly on one test tend to do poorly on all the tests. Make sense? We can figure this stuff out really quick. We can get a lot of insight in our business really fast. Now, if I wanted to in Excel do this, could I do this in Excel? Yeah, take each variable, build a scatter plot, get the R squared. Like you could do this, right? Could you do this fast? Nah, it'd take a little while. And now imagine you're in, I'll use IT. You have a log file for a server. The server keeps going down. You want to know why it's going down. Maybe it's the memory. Maybe it's imagine you grab the log file. You do a correlation analysis. Gives you a nice heat map of all the different variables, lights it up, and gives you the hotspots of, you might want to look at memory, because whenever the memory goes up, the server goes down, right? You can do it like that. It would be hard if you had 100 columns of data to build this manually using a tool like Excel. Make sense? All right. So I'm going to get one more step advanced. Do I have someone in the room that does not know how to code in R or Python? Sorry, I took you out of the running. You were almost going to be able to build a model. But I want somebody to build a model with me this morning that does not know R or Python. Who doesn't know R or Python? Raise your hands. Okay, I see one in the back, one over there, one over here. So one of you, two of you, I'll take two volunteers. You can stay where you're at. I'm just going to ask a couple questions, but one of you is going to build a linear regression model. One of you is going to build a neural network. So our goal is going to be this will be kind of fun. When our kids come home, they're going to tell us their test scores, their reading, math, and science scores. We're going to type them in. We're going to have a model predict their income. And that should work really well because we have all of this great data. We've got countries, we've got reading, math, and science scores, and the actual income. So we can build a model that uses test scores to try to predict income. Does that make sense? So we're going to see if we can build a model to do that. Who's my first volunteer? You want to be my first volunteer? Okay. So we're going to build a linear regression model. And so I'm going to go to the predictive tool suite here. So I'll open up the predictive folder. I'll pull down a linear regression tool. And you only have to answer 2 questions. The first question is, what's the target? What are we trying to predict? And it has to be one of these numerical fields. What did we say we were trying to predict? Income is the predictor, or is the target. And we're trying to predict it with what predictor variables? What did you say we were trying to predict it with? Reading, math, and science. Congratulations, you just built maybe your first linear regression model in the R programming language. Is that pretty cool? All right, so he's got his model built. Who's my next volunteer? You're going to build a neural network. Can you help me out in the back? Yeah, okay. So you're going to build a neural network. So I'm going to pull down a neural network tool. I'm going to pull the same data in. You only have to answer 2 questions, but yours is harder. You have to tell me what it's trying to predict, but the list is longer because a neural network can not only predict numerical fields, it can predict text fields. So this list is longer than yours. But what did we say we were trying to predict? Income, right? And we're trying to predict income with which fields? Congratulations, you just built your first neural network. Do you guys need like a 15-minute break? I mean, I know that was like a lot. By the way, what area do you work in?
I work in data analysis for the business school.
Okay, financial and accounting analysis. And how about you? Okay, and I'm curious, in your professions, do you think from a career standpoint that now that you can build models as well as do what you could do before, do you think there are more jobs in the marketplace that you could go get? And they might actually pay even more money. Is your boss in the room? Make sure your boss knows that you now know how to build models. It's a good thing, right? Same goes for you, right? So this is not only good for you as individuals to be able to add these skills to your capabilities, it's also good for ASU, right? ASU needs people that have these skills to get better insight out of data. It's good for the organization. It's good for the employees as well. Pretty cool? All right. So I know you worked really hard on that neural network. Just to keep the screen simple, I'm going to delete one model so that we keep the screen with just a few tools. Once you have a model, if you want to put it into use, you pull down a scoring tool. I'm going to take the output of the modeling tool and pull it into the model input of the scoring tool. Now, this scoring tool now knows it's looking for 3 inputs: reading, math, and science. So if I pipe into the data feed here, it could be hundreds of columns of data. As long as 3 of the columns are reading, math, and science in any order, as long as it sees that, it's going to append to the end of the data set a score, which in this case is its approximation of income. Does that make sense? So just for fun, I'll take this data. I've got countries, reading, math, science scores, the actual income. I'll pipe that in, and we'll be able to compare the actual income of these countries to the predicted income of the countries, just to see how the model did. Now, this won't be a great model. We're predicting the entire income of a country just using reading, math, and science scores. So it might not be the best model in the world, but let's see how it does. So I'm going to hit run. And when I hit run, it's grabbing the latest data, joining it together. It's building the model. It's already starting to score the model. And we'll take a quick peek at the output and see, in this case, how your model did. That make sense? Okay. So here's the output. And I'll move the window a little bit so we can see all the data. So for Argentina, the actual income in Argentina is about 21,000. Your model predicted 24,000. For Australia, it did great, 48K versus 47K. So it did really well. 52 versus 48 for Australia. And then it got one way wrong. Azerbaijan. People in Azerbaijan, the kids in Azerbaijan, they do great on the test, really smart. They're brilliant, right? And it predicted a high income because of that, but they're not making high income. They're making low income. Any guess why? Related to that, turns out if you have a war in your country, income probably doesn't flourish, because when there's a war, there aren't a lot of opportunities. So I think you're right, but specifically there's a war. Does the model know anything about the war in Azerbaijan? No, it doesn't know anything about that. So if we want to make the model better, the number one way to make models better data. So we might go out to the web and say, for every country in the world, show me the last time it had a war, bring that data in, add that as a column into the training set, model probably gets more accurate for Azerbaijan. So number one way to make models better data. This is why domain experts are actually really good at this stuff, because if you're doing a financial forecasting model, it's really good if you're a financial person, you build the model, you go, it's not working. What is the model missing? You can brainstorm and iterate and try to get your model to be better with better data. The other way to make a model better is the modeling technique. In this case, we used a linear regression model. Maybe it's not linear data and I need some non-linear. I need a neural network. I need some other method. Usually the modeling method is the small knob. The data is the big knob, right? I mean, if we try to predict income in a country and I give it how many clouds are in the sky, obviously the model is going to be terrible, and it doesn't matter what you do with model types. It's never going to be able to do it, right? So the data is the big knob and the modeling technique is the small knob. Make sense? Everybody good? You guys have fun? Okay. I'm going to show you one last example, totally different example to give you a sense of how people usually start their journey. What I showed you is pretty advanced. We just built models. Like that's probably not the first thing you do when you get Alteryx is build a neural network. You might do something simpler. So you said you were in finance and accounting. I'm going to maybe use an example more in that field. I'm going to do something very similar. I'm going to grab some accounts payable data. These are all the people that we're paying, and I have it listed by country. So it looks very similar to that last file. It's a list of countries, but in this case, how much I'm paying people at ASU in different countries. And I think we can agree if I'm paying somebody in a different country, that country should probably show up in my general ledger. So if I look at my general ledger and I don't see that country, something is probably wrong. That would be an audit type of use case. So I'm going to bring down the general ledger data. And here I see a list of countries and information that I have in the general ledger about those countries. So very similar to the last example, if I join these two files together, so I'll do a quick join and join these two files together and join them on country, just like that last example. I think we can agree if there's a country in the top that's not in the bottom, it's in this left file, but not in the right file, they're going to all come out the left. Something's wrong. So I'm going to go to reporting and say, shoot me an email if that ever happens, because that's not good. So send the email to my email address. I just built a 100% audit of the accounts payable to the general ledger. I can now put this on a schedule up here in the corner here, put it up onto a server and tell it to run at 4 a.m. every day. And I have a 100% audit that runs continuously. Now, most auditors historically haven't done this. First, they're in Excel, so they don't do a 100% audit. They do a sample audit because Excel can't handle all the line items of the general ledger and the accounts payable. It's millions of line items, and Excel can't handle that. Alteryx can, so that's good. But I could do a sample audit if I wanted to. Like I could type the word sample and say, bring down a sample tool, and let's do one out of every 1,000 record. Like I could do a sample audit, but why would you? Like that's not modern audit. By the way, if you go to PwC or any of the big four accounting firms, in your first couple of weeks, you're going to be trained how to use Alteryx. Any guess how many users of Alteryx there are at PwC? Actively using it every day? 200,000. Basically, you're not going to be an accountant, an auditor, a consultant if you don't know how to use a tool like this. Does that make sense? So not only can we now do a 100% audit, the audit's going to run every day. And many auditors, maybe even at ASU, they come and say, hey, congratulations, you passed the audit. Great job. I'll see you in 2 years and I'll check you again. And then it's really boring for the auditor because now all they're doing is repeating the same audits every couple of years. They're not really expanding the audit coverage. They're just doing the same thing again and again and again. I would not want that job. Here, what happens is you go, congratulations, you passed the audit today. And we're going to continuously monitor you. If it's ever out of compliance, you're going to know and I'm going to know, and we're going to fix it, right? We're going to get back in compliance. Good. And then all I'm going to do is keep expanding my audit coverage, not repeating the same thing to cover more of the business. Does that make sense? So that would be I don't know, it took me, if I weren't explaining it, 90 seconds. And I just built a full automation of a process that somebody here might be manually doing today, right? Freeing them up, hopefully, to do better things with that time. Could you do it that fast in Python? It'd be hard, right? I mean, you could do it, but it'd be hard. Now, by the way, if you like Python and R, the really cool thing here is I could type Python, pull down a Python tool, and it's opening up a Jupyter notebook on the left, and I can pip install pandas and write some Python code. So you can go from drag and drop, then you could write some code, then you can go back to drag and drop and let these two things interplay with each other. You could also write your Python code, give that tool an icon, an ASU icon. You could email the tool to somebody else and have it show up on their toolbar. So maybe you know how to use Python, you've built something for a colleague to use, but the colleague doesn't actually know anything about Python, but now they can use it in a drag and drop way. That make sense? What's that? Risky, yeah, not so much, not so much. So at the end of the day, that's what Alteryx is all about. So I'm going to pause for a second. Any questions about what you've seen, what Alteryx is, how it works? If not, I get to go back to PowerPoint, but as you can see, I really like playing with data. Yeah, go ahead.
Yeah, I'd love to see some of the functionality around like data preparation and also data acquisition.
Yep.
That would be great to see.
Yeah, so data acquisition, I kind of showed you because I showed you we can read all these file formats and from anywhere, and it's all drag and drop. And you also have API ways of bringing in data and some other ways. So I'm going to pause maybe for a second on acquisition because you saw a little bit of that capability, because acquisition is that easy. You just point to the file and you now have it. But for data quality and how do you like shape the data, I have things like data investigation tools. Actually, no, I don't. Data. See if I can type correctly. First, I'll start with data cleansing. So I'll bring down a data cleansing tool. I'll tell it for all the fields, can you replace the blanks and replace the zeros or the nulls with zeros? I could turn these on and off. Get rid of the white space. I want to change the punctuation or get rid of the punctuation. I want to modify the case from being uppercase to being title case. So these are very quick and easy, data cleansing sorts of things that you might do. We can do, what's the data investigation where I can get my profile? That's what I want. I want a data profile. I can quickly do a field summary as an example. I'll throw one of these in. Delete this. Sorry, keep my screen clean for you. It'd be easier to follow. So with this field summary tool, I can say, hey, for all the fields, give me a quick summary of what the data looks like. This is kind of a key step before you get to, sorry, the mic is hard to balance while I drive. There we go. This will quickly take each of the columns of data and it's basically profiling it for me. So I can see what the data looks like. And I can look at it graphically, or I'll go to more of a table. So here for each column, the salary, the bonus, the tax, it's showing me how many unique values, the min, the mean, the median, the max, the standard deviation, how many missing values there are. And so you can quickly do data investigation sorts of things. You can quickly do data cleanup things. The two tools, and these are 2 of 300 tools in the palette, but these are very like quick and easy, check, check, check. But maybe you need to do something really advanced. And so maybe you need to write some regex. Familiar with regex? And so you need to write some regex. I could bring down a regex editor and basically parse through, write a regular expression. And so we have that full continuum from you're just going to drag and drop and quickly be able to do many things. But if you need to do something a bit more custom, maybe like regex, that would be maybe the next level. And then you could go all the way to, I've got to write code for this step. I'm going to write some Python or R. So it basically has that full continuum. All of the capabilities that you have in, I'll say SQL and Excel for data preparation sorts of things, writing formulas, all the formulas that you're going to see in something like Excel or SQL, you're going to have all of them here, plus many, many, many more. So again, it's got a pretty robust set of capabilities. Again, we've been around for 27, 28 years. There's a lot of engineering in this product. At the deep end of the pool, if you really want to do kind of more advanced things, again, just to give you how broad the platform is. I know you asked about data investigation, but again, this will just get your mind to see how broad this is. I can do full optimization of things. And in optimization, I have linear programming, mixed integer programming, quadratic programming with a couple of different solvers built in. into the product. Right. So again, the breadth is pretty wide here, from simple data exploration, prep and blend. And who again said they used Alteryx? Raise your hand in the room. Of the folks with their hands up right now, who's gone beyond prep and blend? A couple. So most of the folks, when you start your journey, everyone, when they start into data analytics, usually starts with, I just need to wrangle the data around, clean it up. And that's where everybody tends to start. Some have graduated maybe to the next step. They're starting to do a bit more analytical with it. But again, you've got a really wide canvas here. And our hope is we're giving you an upskilling platform that it'll meet you wherever you're at. Maybe you are pretty advanced already. Maybe you're in the middle. Maybe you're at the beginning of your journey. And our hope is with Alteryx, we can help you continue to walk up that path. Make sense? By the way, who wants a license now? Nobody raised their hand, just one. No, oh, we got a couple. Okay. We got a few. All right. I'm going to go back to PowerPoint here for a second. So I'm going to show you a quick picture of what this looks like in a typical stack in terms of how this works with other technologies that you may or may not be familiar with. So I'm going to start at the bottom. Most places have a set of transactional systems that are used in the organization. And you, I'm sure, have probably 20, 30, 50, 100 of them going on at ASU. Usually the only people that log directly into those systems and manipulate the data in those systems are IT folks. By the way, is anybody in the room from IT? No, one. Okay. So you're probably the only one in the room that might be given access to directly create a new view or a new table in one of those systems, right? The middle layer are the data lakes and the data warehouses and the operational data stores. And usually there are many of them. Some of the systems even have their own data layer. So if you have SAP, you probably have an SAP warehouse. If you have some of these systems, they have their own warehouses. In many organizations, they start to build a data lake where they bring data in from many different systems into one place. And again, in the middle layer, the only people that typically log directly into those lakes and modify data in the lakes, most of the time it's data scientists or it's IT in the lakes. It's not the line of business folks for the most part. Make sense so far? And largely it's because you have to know how to code if you want to do that. At the top, there are two different broad categories of types of technologies. There are centralized ones and decentralized ones. On the centralized ones, these are tools, again, mainly used by data scientists, blue people for sure, that they use to go into the data lakes and into the core systems, pull data out, wrangle it around, do analysis, maybe build a dashboard, build a view, do those sorts of things. And the tools on the right, again, are designed for blue people, for the highly technical IT sorts of folks. And we could put lots more logos up there, but these are just examples of types of tools that fit on the right. That again, typically an accountant doesn't use the tools on the right. On the left are democratized tools. These tend to be tools that anyone in the business uses. IT can use them too, but so can everybody else. And so a tool like Tableau or Power BI tends to be on the left-hand side. Alteryx fits on the left. IT can use it, but so can everybody else. And in most modern organizations, you want to have a few tools that fit in the left-hand box. Because A, you need the line of business to be able to do last mile work, to be able to analyze data. First reason. Second reason, you should have some tools that everybody can use. That if you build something and you need help from IT, IT could also use it and you could go back and forth and there's not a language problem because you use two totally sets of different technologies. And Alteryx fits on that left-hand side. Now, in many organizations, what happens is that you bring in these tools on the left for really the line of business to be able to use. And sometimes the tools on the left replace tools on the right. Never happens the other way because the tool on the right can only be used by IT. So the tools on the right don't usually replace tools on the left. So I'll use like IBM Cognos. Has anybody here heard of IBM Cognos? I don't know if you use it here. Do you guys use IBM Cognos here or no? What's your dashboarding technology here? Do you have any that just IT builds in? Yeah, so if IT builds something in a technology just for IT, it might be a tool like Cognos. So Cognos is a dashboarding tool. But if you brought in Tableau it would be very likely that eventually IT might start building dashboards with Tableau because they're like, this is pretty cool, easier to use than Cognos. And eventually they stop building things in an older tool like Cognos, and Tableau is kind of displacing Cognos. Alteryx kind of fits that as well. Like your IT team might use DBT or SnapLogic or Informatica to do ETL and to manipulate data. But over time, if you have a tool like Alteryx, they sometimes start using Alteryx as well. So this is typically where we fit into the broader stack of an organization. So I'm going to pause here. Any questions, comments? Yeah.
I'm gonna just share real quick
Yeah.
how we do have.
Yeah.
So for anyone that doesn't know, here at ASU, we do have Salesforce. I know in Ed Plus, they do connect from Alteryx directly to Salesforce, both pushing and pulling. We also have Workday in the data warehouse, which is in Redshift. We don't have Snowflake here. We have an analytics user database that we've built that's in Postgres where people can write themselves. Anyone can, and you can request that yourself. And then we have S3 Data Lake too. So we have a lot of different options for anyone. And any of, when you talked about data acquisition, if it's out there, you can connect to it. You just have to work through our ET office and they'll help you get connected to the various sources that we have here. So we've got a lot of this already going. So it's great.
Any other questions? Guys are so quiet. It's sunny out. Everybody wants to go back out to the beautiful weather. I'm from Michigan, so I definitely want to go outside. So I'll stick around for a bit if anybody does have questions. If people are interested in trying it out, I think we've got the perfect folks here because you could probably steer them in the right direction of how that happens here at ASU. And we've got a couple of our folks. So if people want a trial license or want to explore and learn more. If you are new to this, hopefully you can tell we're really passionate about this upskilling piece. When you have a license, you actually have access to our full academy. And in our academy, we have courses, they're all free and included. We have courses online on demand that teach you how to do these things. We also have weekly challenges, which I personally love. The weekly challenges are like crossword puzzles. We give you data, ask you a problem to solve, like a crossword puzzle. Yes, we give you the answer key. Just like a crossword puzzle. And you can try to solve the problem, of course, before you look at the answer key, and then look at the answer key and learn how to do it that way. So we've got lots of training content built into the platform as well. Well, with that, thank you very much. It was great being here this morning. Good luck letting your boss know about your new found neural network skills and linear regression skills. Let me know how the salary negotiation works out. But it was great being here with you. Thanks.
One other thing I do want to say, we also in the analytics portal, there's an Alteryx group and it has a lot of different things. Matt Hines, who's in the back, did a lot of help for us to set up the level 1 certification that's out there recorded. You can go and you can do that. And there's a lot of resources, and there's an Alteryx user group too, if you want to join. Josh Johnson's always looking for people to show things that they've done as well. So thank you very much.